and welcome to the class. The first thing that you need to do is you need to go to a plus students.com. You need to log into the website. Okay. Once you have logged in, what you need to do is you need to select math as your subject. So let's select math. Okay. After selecting the subject, you select your grade level. Your grade is grade 7. We are doing grade 7 maths today. Okay. The topic for today is geometric measurements. Let's look at the topic. The topic is geometric measurements. Okay. Once we have found the topic geometric measurements, let's look at the chapter number. The chapter number is 22. The chapter number is 22. And the lesson for today is, lesson number is, I'll just give you the lesson number. The lesson number is 9 for today. And the lesson number is 9. And the name of the lesson is perimeter, area, and volume. Okay. And we would be looking at the changes in scale. So let's do this. Let's go to the chapter. Let's go to grades. Select maths, grade 7, chapter number 22, that is geometric measurements. And the lesson number is lesson number 9. Okay. Let's see the first question. Okay. I'll just copy the question so that we have it on our screen. Okay. It's just the basic they're asking us. Okay. We start off with question number 1. And the question number 1 says, look at this rectangle. Okay. And if the height, there's a statement given. Okay. And it says following. Okay. If the height of is triple, then the width of the following statement of the above the area is question number 1. Okay. For this rectangle, the base, the length was 9 inches and the height was 10, right? They both are different because it's a rectangle. They should have a different, right? So can we say that we can find the area for this triangle, right? The area should come out to be length times height. That means the original area should be, the length was 9 times 10, that the original area should come out to be 90 inches squared, right? But what they're asking us is, if the height is tripled, for the new shape, now the height has been tripled. So that let's draw a rough sketch. That means if this was the base or this was the height, if this was the height, now the height becomes 3h. Okay. What was the base? The base stays the same. We know the formula for area is length times height. But since the height for this shape has changed, so we can say length times, what is the new height? It's triple, that means 3h. Agreed. So can we say the area is equals to 3 times length times height? Okay. 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 The statement over here is that which of the following statement of the area will be correct? Let's make some statements over here. Okay. Let's suppose if I say statement number A says that if the height is thrice the new area is 9 times the original. Okay, that is statement A. Let's look at the statement B. The new area is 3 times the original. Okay, so just let's see which statement is true, because they're asking us over here which of the following statement is true. We've got two statements over here, right? So let's see which statement would be true. So whenever we need to do this comparison of the areas, right? So what we do is we say, let's suppose we say new area upon the original shape, right? Upon the original shape, original area. Let's take out the ratios. The new area was 3 times length times height. Agreed? Whereas the original area was length times height. Right? Agreed? So in this, we can cancel the length with the length and we can cancel the height with the height. So we can say that new upon original is equals to 3 upon 1. And we can cross multiply, right? So we can say that the new area is 3 times the original area. Agreed? So which statement is true? The second statement is true. This statement is true. And this would be false because it says 9 times, it says 3 times, right? So statement B is correct and original for us. The new area is 3 times the old area or the original shape, right? Agreed? Let's move on to the next question. Let's see. Okay. I'll just create the second part of the question. Okay. If a cube is given in the next one, a cube is given to us. Okay. I'll give you a hint as well to make our lives easier in the end. In question number 2, it says, let's look at this cube and which of the following statements is true. Okay, let's see. Just a minute. Let me align this first. Okay, let's create the statements. If they're saying that in question number 2, there's a cube which has the dimensions 10, 10, and 10, right? If the side length is tripled, only the length of the side, okay? Because we have 3 dimension, right? Okay, let's see if they're asking for one side or more than one side that needs to be tripled. Okay, since it has a plural over here, side lengths, it's a plural over here. That means in the new shape, all the 3 sides will become thrice. All 3 sides are changing in the new shape, right? So what we can say is, if this was the shape given to us, that was the original. Let's create a new shape. If all the sides, the lengths were tripled, that means the lengths would become 30, 30, and 30, right? If all the lengths are thrice now, tripled, that means this becomes 30 centimeter, this is 30 centimeter, and this is 30 centimeter now. So what if we would say this is shape number 1, right? So we say volume 1, we say volume 2. So if I need to find the volumes, right? So can I find the volume 1? That means length into width into height. The volume 1 comes out to be 10 multiplied by 10 multiplied by 10. The volume 1 comes out to be 10 multiplied by 10 is 100. 100 multiplied by 10 is 1000. Agreed? This is volume 1 of the original. Okay, original shape. But if we need to find the volume of the shape where the lengths have been changed, so we can say volume 2 would be equals to the new length multiplied by the new width multiplied by the new height. This was 30, right? The lengths have been tripled. All the sides lengths had been tripled. Times 30 times 30, right? And we know how to multiply by the numbers ending with 0. 3 multiplied by 3 is 9. 9 multiplied by 3 was 27. And there were 3 zeros. Agreed? This is centimeter cubed. Okay. So if we need to find, we write a statement. I'll give you the two statements. We'll find the first or the second. Statement number 1 says the volume of the second cube is 9 times the original. Okay. Or it could be 9 times the original, or the second statement we will create is we need to find which statement is true. We're just creating statements over here. Okay. The volume of the second cube, that is the enlarged cube, is 27 times the original of the original, right? So let's see. All we can do is we can compare the volumes and we can find the ratio of the volumes. So V2 was a new divided by V1, that was the original, right? V2 is given as 27,000 divided by the original volume, that was 1,000. So we can simply cancel out the zeros. So can we say that volume 2 upon volume 1 is 27? And when we cross multiply, that means volume 2 is 27 times of volume 1. So which statement should be the true? The new volume is 27 times the original, right? Times the old volume. So which statement should be correct? Can anyone answer? Statement number 1 or statement number 2? Because we have two options over here. Following statements were 2. The volume of the second cube is 9 times the original. Or the second statement was the volume of the second cube is 27 times. So whenever we need to find the ratio, we found the volume and we compare the ratios. So volume 2 when compared with volume 1, that comes out to be 27 times, right? So what we can say is the volume of the second cube is 27 times the original. This is true. This second statement is true and this is false. Okay, we don't have to define false, but we are just writing false so that we know which statement is true and which is false. Okay. Moving on to the next question. Let's do the next question and let's see which statements we need to see. Okay, let's do question number 3. When you click on to the next, you will still have the same question on your screen. I'll just copy the question. Okay. Okay. The question says, okay, look at the rectangular prism. And they are saying if all 3 dimensions are doubled, okay, which of the following statement will be true? Okay, let's create a statement over here. Let's make some statements and see if they are doubled. Okay. Surface area. They're talking about the surface area. I'll just make 2 statements over here. The statement number 1, let's suppose option number 1 given as the new surface area is twice the old surface area. Okay, we have one option. Let's look at the next one. The new surface area is 4 times the old surface area. Okay, let's see which of these two statements would be correct for question number 3. Okay, so if we have a shape, right? That's a cube is already given to us. We need to see when the dimensions are doubled. Okay, let's create another shape and let's increase the size. When the dimensions would be doubled, the values will change, right? This was 5, this becomes 10, right? This was 5, it becomes 10. This was 8 yards, this will become 16 yards since the dimensions are doubled. This was 6, this becomes 12 yards, right? So can we say this is volume 1 or the surface area 1, right? Let's do surface area. We need to do surface area. This is area 1 and area 2, right? We know that the formula for the area is surface area. The formula for surface area was there are total 6 sides in a cube, right? So we can say surface area of the old shape, right? We can say that means length multiplied by the width plus length multiplied by the height plus width multiplied by the height. This is the formula for the surface area. Agreed? But now, if we need to find the surface area of the new shape, that is the new shape, right? That means each dimension was twice. Agreed? So in place, we can write the same statement. We can say 2 from the formula. The length is twice now, right? So can we say 2 twice of length is multiplied by twice of width plus the new length was twice, the height was twice, the width was twice, and the height was twice. Agreed? This would be the new. Simplifying this, by simplifying this, can we say this is 2 stays over here? This is 4 length multiplied by width plus 4 length multiplied by height plus 4 width multiplied by the height. We are just simplifying the formula before putting down the values in it, okay? So can we take 4 common inside? Can we say 4 comes over here because every single value has a 4 over here. 4, 4, and 4. Can we take 4 common? Therefore, can we write this as length multiplied by width plus length multiplied by height plus width multiplied by height? And 2 and 4 when multiplied together, it becomes 8 length multiplied by width, length multiplied by height, and width multiplied by height. Agreed? So what we have here is the new surface area, and what we have over here is the old surface area. So whenever we need to find the value of the ratio, so what we do is we compare them. So can we write new surface area upon the old, right? This was new and this was old. So we can say 8 is multiplied by length times width plus length times height plus width times height compared to 2 length times width, sorry, plus length plus, we're just simply copying this formula over there, plus length times height plus width times height. So when we have two values similar in the numerator and denominator, we can cancel out these values. What are we left with? We are left with 8 upon 2, which simplifies to 4. Agreed? That means the new area This was new upon old. And when we cross multiply, so we can say new area is 4 times the old area. Agreed? So which statement should be true? The second statement should be true because it says 4 times. Over here it said twice. It's not twice. So this is true for us. And this statement is false. Okay. What we are doing in this question is if the dimensions of any three-dimensional shape have been changed or a two-dimensional shape has been changed, right? So what we do is we change the length in accordance to the question, because if there are three dimensions are doubled, they were saying all three dimensions are doubled, so we simply double the dimensions. If there are three times the dimension, then we make it three. The length would be three times, okay, depending on the question. And then we need to see which of the statement would be correct. Okay, let's move on to the next question. Any questions up till now? If there are any questions, we'll discuss those first. Okay, thank you so much. Let's move on to the next. The next question says, look at the rectangular prism. Okay, this, they're calling it a prism. A prism can also be, it's a three-dimensional shape made out of either triangle or it's made out of a rectangle. A shape made out of rectangle would also be a prism. Okay, so we have the third question. I'll just say this is question number 4. Sorry, question number 4. It's a rectangular prism. If the length is tripled, it says the length is tripled only, right? Not all three dimensions are changing. So what we can say over here is, if we take this shape again, we copy this and we say if the length is tripled, can we say this shape would become something like this? Okay, if this was the length, then this is 3 times the length now, right? This was the height stays the same. And if this was the width, then width stays the same. Only if the length is tripled, which of the following statements would be true about the volume? Let's create some statements over here. Let's see. If first statement I say is the new volume is 3 times the old volume. Okay, first statement. Let's look at this another statement. The new volume is 9 times the old volume, right? So we have two statements. Out of these two statements, we need to find which of the following statement about the volume is true. Okay, so we know that in order to find the volume, we can say this is volume 1. So if we need to find volume 1, we can say length multiplied by width multiplied by height. So we can say volume 1 comes out to be length, width, height. Agreed? We're not putting down the values. We can put down the values and we can still find the answer. We're just simply trying to find the answer through the variables. Okay, you don't have to do that work. Volume 2. So in case of volume 2, the formula was still again length times width times height, right? But over here we know that the length has been changed to 3 times the length. The length will be replaced by 3 times the length, because it says over here the length is tripled. Okay, times width times height. Height and width were same, so can we say volume 2 is 3LWH, right? And if we need to find the comparison, so we say new volume upon old volume. That would mean new volume was 3 length width height divided by the old volume was length. It was length, width and height. So if we have anything common, we can cancel it out. Agreed? What are we left with? we are left with new volume upon old volume is equals to 3. When we cross multiply, can we say new volume is 3 times the old volume? Okay, so which statement should be correct? Option A or option B? Can anyone answer? Which statement is correct? The new volume is 3 times the old volume, or is it 9 times? Yes, correct. Option number 1 is true for us, right? Because it is 3 times the volume. It says 3 times. Then this statement is true. And this statement is, the second statement is false. Okay. So what we can see over here is, in a 3-dimensional shape, right? If one dimension is changing by a certain ratio, in this question, one length was changing by 3 times, right? So it will only be thrice. But in the previous question, what happened was, that was surface area, right? So let's look at another, right? We'll do another example in which we'll try to change 2 lengths. Okay. Let's look at the next question. Okay. Moving on further to the next question. It's again 2-dimensional, and in 2-dimensional, it would always be about the area. 3-dimensional is volume, 2-dimensional is area. Let's copy the question and let's make some statements about it. Okay, we are trying to make our own statements so that we'll have a better understanding. Okay, previous question was 4. This becomes question number 5. Okay, a rectangle is given. What they are saying is, if this part is the length, this is the height, right? The height is doubled. Then which of the following statement is true about its area? Okay, let's make 2 statements about the area. Let's say the first statement is, the new area will be twice of the old area. Okay, and the second statement is, the new area will be 4 times the old area. We've got 2 statements over here. Let's see which statement would be true and which would be false. I'll just make a partition over here. Okay, so if we have the same shape, but what is changed? The height is changed, right? So if I would say we have another shape like this. Okay, so what happened over here? Length stays the same, but the height becomes 2h. So this is area 1 and area 2. Rather than doing work separately, what we can do is we can do it together also. We can say new area divided by the old area. The formula for the new area is length times width. Length area would always be equals to length times height in this case, right? So the old area was, the length was length multiplied by the height, that is 2h. What about this? Length multiplied by height. Right. So can we cancel out something that is common? The lengths are common, the height is common. What are we left with? New area upon the old area would be equals to 2. When we cross multiply, we can say new area is twice of the old area. So which statement is true? Statement number 1 is true. This is true for us because the area will be twice. And this is false. It's not 4 times, right? Let's prove it by putting down the values as well. Okay, we can always put down the values and we can do the working as well. So we can say that area 1 that was given to, I'll make the shape again. So now let's try doing it by the values we have. Okay, If this was area 1, length was 10 millimeters. Okay, agreed on that? Because I'm just copying the value from here. And the height given was 6 millimeters. So what can we say about the area 1? Area 1 would come out to be 10 multiplied by 6. Area 1 comes out to be 60 millimeters squared, right? But if we would change the height, to be twice, okay, the length stays the same, 10 millimeter. This is area 2, but the height was 2h. That means 12 millimeter. Height is 12 millimeter. So what about area 2? Length multiplied by the height, that is twice now. The area number 2 of the new shape comes out to be 120 millimeters square. And we can say that new area upon the old area, that would be A2 divided by A1. We can say 120 when divided by 60. That means 2 is left. So we can say new upon the old is still equals to 2. When we cross multiply, we can say new area is twice of the old area. We could have done the same question by putting down the values, or what we can do is we can simply do the question by assuming the variables length and the height. Okay, vice versa, we'll always get the same answer, whichever approach we have. Okay, let's look at the next one and let's see what they're asking us to do. Okay, so the next question says we again have, okay, what we have a rectangle with both the dimensions changing. Okay, you need to see something. If in this previous question we saw that only the height was doubled, right? One dimension was changing, it became twice. But if both the dimensions are being doubled, that means it would become 4 times. Let's see. If both one dimension is doubled, then it is twice the area. But if both length and height both are changing, then it would be 4 times. Let's look at the question. In question number 6, what they're asking us to do is we have a shape. Let's see, the statements will be true. Let's create 2 statements for ourselves. Okay, just a minute, please. Okay, thank you. Question number 6, they say, look at the rectangle. The length is given as 7 feet and the height is given as 4 feet, right? If both the dimensions are doubled, okay, if both the dimensions are doubled, can we say that it would become something like this, that this would become 2 times the length and this would become 2 height, right? Let's make the statements over here. The first statement will be we are looking at the perimeter. They're not asking us about the area, they're asking us about the perimeter. Let's see what happens. The new, it's perimeter, right? New perimeter is twice the old perimeter. What is perimeter? The perimeter is the amount of material required to make a shape. That means the outer boundary, or the new perimeter is 4 times the old perimeter, right? Let's see what should be the answer. So what should be the perimeter of shape 1? Perimeter 1 would be length plus height plus length plus height. That means perimeter is 2 lengths plus 2 height. That means perimeter comes out to be 2 length plus height. That is perimeter 1 of the first shape. If this is perimeter 2 of the second shape, so we can say perimeter 2 would be, see, this is 2 lengths and this is two heights. So we can say 2 lengths plus 2 height plus 2 lengths plus 2 heights. You're adding simply the 4 sides. Or we can say 4 lengths plus 4 height. Can we take 4 common? Can we say length plus height? Once we need to find the ratio. So in order to find the ratio, we say new perimeter divided by the old perimeter. That should be equal to new perimeter is 4 length plus height divided by the old perimeter, that is, sorry, this was 4 length plus height, right? And the next one is 2 length plus height. So can we cancel length plus height because it's the same in the numerator, it's same in the denominator. This becomes 4 upon 2, which can be simplified to 2. So the final statement can be written as new perimeter is, when we cross multiply, is equals to twice the old perimeter. So which statement is correct? So once we look at both the statements, the first statement said the new perimeter is twice the old perimeter, right? That means, and we did find that it is twice the old perimeter. So this statement is true for us, and this statement is false. The perimeter does not equal to 4 times the old perimeter. It would be only twice the. Whenever we have perimeter, volume, or surface area, what we need to do is we need to put the values into the formula, right? Simplify the formula and you'll find the ratio. Okay, let's try a question or two from the test, a few questions from the test. I'll just copy from the test. Okay, please do complete the remaining questions from the test. Just a minute, please. Okay. Okay, I'll just copy this. We'll do it quickly. Let's see. This is the rectangle given. And okay, the question from the test, question number 1. I'll just give the heading of test so that you remember it's the test. The remaining you have to complete yourself. Okay. And the first question given was this. Question number 1 from the test. This is option number A. This is option number B. Let's see which option is the correct answer. It says if both the dimensions are tripled, that means if this was length and this was height, right? In the new shape, what will happen? This would be 3 times and 3h, right? We need to find about its perimeter. Okay, I need you to help me out. In part, the option A says the perimeter will be 3 times the old perimeter. Okay, or say the perimeter would be 4 times the old perimeter. In this case, the easier way to do this question is, this length was 5, then this would be 5, this was 3, and this would be 3. So we can find perimeter 1. Perimeter 1 becomes 2, 5 plus 3, because the formula for the perimeter is 2 length plus height, right? Or length plus breadth. That would be 2, 8. Perimeter 1 comes out to be 16 centimeter. Let's look at perimeter 2. If this was 3L, then this is 3L and this is 3H. Length was 5. This becomes 15. This is 15. This was 3. So this becomes 3 times 3. That is 9. And this is also 9. So can we say perimeter 2 would be the length plus height or the width? The perimeter 2 comes out to be twice. The length was 15 plus 9. 15 plus 9 is 24. And perimeter 2 comes out to be 48 centimeter. We need to find the ratio. So we can write perimeter 2 divided by perimeter 1, that is 48 divided by 16. That means perimeter 2 is 4 times of perimeter 1. Let's see. The new perimeter will be 4 times. Option B is the correct option, right? I did one question for you so that the next question you need to do, okay? Thank you. We go to the next question. Okay, I did one for you. The next you have to give me the answer. I'll just copy it on the screen. When you click next, it's on your screen as well, right? So the question number 2 says, I'm just copying it for the sake of explaining. It's already there on your screen. Okay. Let's look at this. The second question of the test says, look at the rectangular prism, and they're talking about the surface area. I'll tell you the formula for the surface area is surface area. Surface area would be 2 length time width plus length time height plus width times height. This is the formula for the surface area, right? Because there are total 6 surfaces, right? So let's do this. Can I have the answer? I'll read the question. If all the 3 dimensions are doubled, okay, so what should be the surface area? Option A or option B? The easiest way is to make another diagram or just suppose another diagram, right? The easier way, if all the 3 dimensions are doubled, the 3 dimensions doubled would become, this was 8, 16, 5, and 6, right? So this should become 10. This should become 16, and this should become 12, right? Can you help me out with this? Area 1. 5 times 8 plus 5 times 6 plus 8 times 6. 5 times 8 is 40, 30, 48. 40 plus 40 is 80, 80 plus 110, 118. And this finally comes out to be 118 multiplied by 2 is 100 multiplied by 2 is 200. 18 multiplied by 2 is 36. So this area 1 comes out to be 236 yards square. What about area 2? Please do area 2. We multiply these two together first. 10 multiplied by 16 plus 10 multiplied by 12 plus 12 multiplied by 16. Great. You can use a calculator also. 10 times 16 is 160, 120, right? And 16 times 12 should be 192. So when we add 192 plus 120 plus 160, right? It comes out to be 472. And 472 multiplied by 2 is 944 square yards. This is area 2. The new surface area would be how much? All we need to do is, what do we need to do whenever we need to find the ratio? Please answer this. Help me out. See, we found the surface area of both the shapes, right? But we have 2 statements over here. They are saying that the new surface area be 4 times the old surface area, or would it be twice the old surface area? How can we find the ratios? We know that whenever we need to find the ratio, what do we need to do? Yes, good answer. We need to compare, right? We need to say, so we can say surface area, area 2 upon area 1, right? That should be, it came out to be 944 divided by 236. Is it twice or is it 4 times? Divided by 236, right? It comes out to be, sorry, it comes out to be just area 1, 4 times. So can we say area 2 is 4 times of area 1? Agreed, right? That means, yes, that means option A was correct. Thank you for the answer, right? So we click on option A and it would show us whether our answer is correct or incorrect, right? It's correct. Okay. You have a few more questions left in this topic. Please, after this class, go there, go to this topic, do the test, complete the test, right? And if there is any problem, just go through the video, revise and do the video, okay? Thank you so much for your time and best of luck. Take care.